Okay, everybody, we're going to go ahead and work through a Unit 1 checkpoint review, and when we are done working through this, then I'd like you to study it, go back through it, make sure that you understand how to do it, make sure that you write this down as we go through it. You can print out the worksheet from Schoology, or you can just go ahead and write it on a piece of lined paper. But these are all concepts that we went over last semester. We talked about function notation. Once again, the main concept, the overarching concept here that we're talking about is linear. Everything is linear, right? So we're talking about lines, all right? And this one right here, it says if the function f is defined by f of x equals 6 minus 2x, graph y equals f of x, right? So first thing I have to do is I'll go ahead and put this into a form that I know. I'm going to go ahead and write my name up here. Write today's date. And let's call it period 0. Alright, so function notation is y. Another way of writing function notation, what we normally write it as, is y equals mx plus b. B is our slope. Okay? Or sorry, m is our slope. B is our y-intercept. Okay? So we can also look at it, function notation. Every time, whenever we say function notation, we can just replace it with what we call the function. And the function here is called f. Alright, so the function is called f. And the variable that we're looking at is x. So you're going to see whatever your variable is, you can see that in this is slope-intercept form. You're going to see that variable in the equation not only on the left-hand side where we would usually see y, but on the right-hand side right after the m, the slope. So okay. Alright, so in slope-intercept form, we have this right here, and if we write this out, we could say, we could change this around by saying f of x equals negative 2x plus 6. So I have my x term here and my y-intercept term, or my b term right there. So m is negative 2 and b is 6. B tells me where to start from. So B says to go up on the y-axis right here and put a point right there. That's our starting point. Okay, so that starting point is at 0, 6. And so remember that your y-intercept, your b value, is where x equals 0. Okay, x equals 0, and then whatever the y is, where x equals 0. Okay, so that means that I'm not going anything left or right, I'm just going straight up to 6. Alright, so my slope, we can call it negative 2, or if we talk about rise over run, we could say negative 2 over 1. Okay, which would mean that I'm going to go down 2 and right 1. So from there, I'm going to go down 2 and right 1, and I'm going to put a point. And then I'm just going to, that geometric approach that we have been talking about last semester, that's what I'm going to do. I'm just going to continue to do that and create these triangles. Down 2, right 1. Down 2, right 1. Okay? And then I'm going to go ahead and draw my point, or draw my line. Okay, makes sense? Okay, here's number 2. So this one, it says the distance an electric car can travel on one full charge depends on the speed of the car. The table shows the approximate distances for my Ford Focus Electric. The approximate distances my Ford Focus Electric can travel on one full charge when moving at various constant speeds, right? So this is my car. This is what my car does, and I think we've gotten a charge of up to like 80, but that's rare. But we'll just call it 70 is the maximum charge that you can get on this Ford Focus Electric. It says the speed and the corresponding distances form an arithmetic sequence. Okay, arithmetic sequence is something that looks like, here would be an arithmetic sequence as an example. 2, 4, 6, 8, 10. Right, those are the even numbers. That's an arithmetic sequence. Right, so my first term, second term, third term, fourth term, fifth term, right? And what we're doing here is repeating this addition of 2 every time. Okay, so that's a constant, right? Okay, so with that understanding, it says it forms an arithmetic sequence where the speed represents the number of the term and the corresponding distance represents the value of the term. Okay, so speed and value. We talked about ordinal and cardinal numbers. Okay, so ordinal numbers are the number that it is within the order, right? And the cardinal number is the value of it, right? Okay, so speed is the number of the term, and the corresponding distance, the distance represents the value of the term. What is the distance in miles that the car can travel on one full charge when moving at a constant speed of 75 miles per hour? Okay, so 75 at a constant speed of 75 miles per hour. Okay, all right, so here what we have, if we can just kind of get it, remember these are all linear, so we can assume that these things are going to have a constant rate, and a constant rate means that the change in y over the change in x is going to be the same thing every time. Okay, all right, so the decrease is 5 miles for the distance. Okay, so if we're traveling faster, that means we're going to get less distance out of the car because it just takes more energy to travel faster, right? Similar to your body, you're not going to be able to, if you're going faster, you're not going to be able to last as long, right? Okay, so then on the right hand side it says speed in miles per hour. This right here is an increase plus 5. Okay, so plus 5. All right, so now we look down here, it says 65 miles per hour. Well, I know that, 65, just looking at the numbers here, 65, 75, those are all multiples of 5. Okay, so the miles per hour that I'm looking at, I want to know what that distance is going to be at 75 miles per hour. Well, I'm just going to go over here and I'm going to create another, a continuation of that speed chart and say speed. Okay, and that's miles per hour. And distance, right? And we'll say miles. Okay. Well, to continue, if I go 65, the next one would be 70, right? So I go 70, what would the next one here be? I'm subtracting 5 from it, so that would be 45. Okay? And then the next one is going to be 75. And so where would I be at? How far would I be able to go if I'm traveling at a speed of 75 miles per hour? Well, in theory, okay, I would be able to go 40 miles. All right, so 40 miles around town. So basically, my Ford Focus Electric is just a town car. I can cruise it around if I was going to work and back. Everything, it'd be plenty of distance and everything to go to work and back. But I'm not going to be able to go to Denver and go all over the place. All right, so I just answered that question. It says, what is the distance in miles that the car can travel on one full charge? The distance is 40 miles at 75 miles per hour. Okay, so that's my answer. And that's how I always want to go back to things and put them into the context of the problem. Okay, so it says 5 blank 15 blank blank 30. The first, third, and sixth terms of an arithmetic sequence are shown. What's the common difference? The common difference. Okay, so we got to go back to common difference between consecutive terms in the arithmetic sequence. All right, so if I look at this, my first term, second term, third term, fourth term, fifth term, sixth term, right? So they say that it's an arithmetic sequence, which means by definition that there's going to be a constant rate. Okay? So it's not, now here's the thing, it's not asking you about what filling in those spaces, although filling in those spaces will definitely tell you what the common difference is going to be. It's asking you about what is the common difference. The common difference is the difference between the first term and the second term, right? So what I do is I look at this and I say, okay, what do I know? I know 15 and I know 5. And that represents the first term and the third term. Okay? So the common difference here is going to be 15 minus 5, because that's the difference between 15 and 5. And I'm going to put that very similar to, this is slope. Common difference is your slope, right? So change in the y values over the change in the x values, and that's kind of what it is. Over 3 minus 1. Well, why did I say 15 and 3? I started with the third term. Okay? So the value of the third term is 15, and the third term is represented by a 3, right? That's the ordinal number for that. And then I went to the first term. The value of the first term is 5 right here, and the first term is represented by 1 as far as the ordinal number is concerned. All right, so I just go ahead and subtract it, and I say 10 over 2, which equals 5. So D equals 5. All right. Now, just to make sure, I always go back and check and see if that's correct. So if I add 5 to 5, I get 10. If I add 5 to 10, I get 15. So that's correct so far. And then if I continue on with that, I'm going to say, all right, well, here would be 20. This would be 25 and 30. So that would make sense. That's totally reasonable by looking at it that way. Okay, so my next one says, what is the rate of change? Rate of change is the change in y, okay? So we're going to call it y1 minus y2 over x1 minus x2. Very important little detail here is that I start with, if I start with y1 on the bottom, I have to start with x1. I can't go y1 up on the top and then say x2 down here on the bottom. All right? So that's an important part of this. All right? So I have the y values in in the x values. Okay, so we're going to call this point, this will be our first point, and we're going to say this is x1 and this is y1. So therefore this would be x2 and this would be y2. And now what we're going to do is just plug in what we have. So what's y1? Well, y1 right here is 4. What's y2? 1. Okay? And on the bottom I'm going to say x1. Okay, so what is x1? x1 is 5. Okay, what is x2? x2 is 30. Okay, so now what I do is I just go ahead and subtract. I say 4 minus 1 is 3, and I'm going to say 25 right here, right? Because 30 and negative 30, when the signs are different, we subtract them and keep the sign of the bigger number. So negative 30, subtract the two numbers, so 30 minus 5 is 25. And what's the bigger sign? The bigger sign is negative. So we can write it out as the rate of change is negative 3 over 25. Okay, so we're going to go down 3 and to the right, down 3 and to the right 25. Okay, so it says for number 5 tells you about the graph that's above here. Tell me about the above graph as it relates to points on the x and y axis. Okay, so as x, here's x, as x increases, okay, as x increases, it goes to the right. All right, as x increases, y does what? Y goes down. All right, y decreases. Okay, simple one, right? Just got to read it, read the graph. Get very good at reading the graph, guys. All right, so the table shows 4 x values and the corresponding y values. What do you notice about the values as they relate to direct variation? Okay, so what is direct variation? We got to understand that. Direct variation is this thing called y equals kx, right? Y equals kx is the same thing as y equals mx. And it's the same thing as that slope-intercept form that I had written down earlier, mx plus b, but for direct variation, b is 0. So what that means is that it's not that there is no starting point or there is no y-intercept. It means that the y-intercept in direct variation, b equals 0. Okay? Because there's nothing, we wouldn't have to write down plus 0, right? We don't need to do that. Okay, that's just repetitive. We don't need to do that. So it says, what do you notice about the values as they relate to direct variation? Okay, so one of the things about direct variation is that our k value is going to be y divided by x every time. Okay, so now we could have a line where y divided by x is not the same thing every time, but it's still a line, and that's for any line that has a y-intercept that is not 0, right? We will have that point where y divided by x is going to be different, all right? But special case here, k, which is your, basically your m here, every time we take y and we divide it by x, we're going to get the same thing, okay? So what I'm going to do is just map that out. Just say 2.2 divided by 1. Well, what does that equal? 2.2, okay? Then I take 4.4 and I divide that by 2, and what do I get? 2.2. And then I take 6.6 and divide that by 2. Well, guess what? 2.2. Okay, and then on the other side here, I get 8.8 divided by 2, divided by 4, which equals 2.2. Okay. It says, what do you notice about the values as they relate to? Okay, so this is direct variation. Okay? Because this happens every time. Okay? Y divided by X is going to be the same thing every time. All right? And that's what we showed right there. Okay, 7. Important one. Okay, this is for your bank account later on, right? So bank account right here. Robert opens a bank account. The amount in dollars in the account X weeks after the account is open can be modeled by the function f. Okay, so x and f. So it's going to be this thing. We're going to call it f of x. Okay. If Robert has $4,000 in the account 15 weeks after the account is open, write that point in function notation and explain where it would fall if you graphed it in the xy plane. Okay? Alright, so remember, the x value is weeks. Okay, f of x, okay, that function f of x, right, and that's how we rewrite function notation. We write function notation as it relates to the other variable. The other variable is weeks. So f of x equals the amount. Okay, in the bank. Okay, all right. So f of x equals some. So what's the amount? So the amount, if we say f of x, well, f of x equals 4,000. Okay. X in this case equals 15. Okay. So how do we write that in function notation? We just go in here and we just replace them, right? So we replace the variables with the numbers. So f of 15 equals 4,000. Okay? All right. And explain where it would fall if you graphed it in the xy plane. All right? So you would go right 15 units because like you could write the table out here, x and f of x, just like x and y, same thing, just remember. 15, 4,000. You could also write it as a point. 15 comma 4,000. And what that means is that we're going to go right 15 units and we're going to go up 4,000. And those are my answers for it. Okay. All right, so Principal Perez purchases boxes of pens for his school in an online store. The store charges him the same amount for each box. So same amount, that means constant rate for each box of pens plus a flat fee for any number of boxes he purchases. Okay. Selected numbers of boxes and the corresponding total cost, including the shipping fee for that number of boxes, are shown in the table. Okay. Let t be the t is going to be the function, so I could write that out as t of something, right? Be the function that models the total cost, including the shipping fee in dollars. to purchase P boxes. All right, so P boxes, or boxes of pen, okay, so P equals boxes of pens, T of P equals amount we'll call it the total amount. Total amount. Okay. All right, so it means the total amount, no matter how many boxes of pens we order, right? All right, so based on the values in the table, write a function t in relation to the number of boxes of pens. All right, so we have to find, when we find a function, we have to find m. M is going to be our slope, and we have to find b. B is going to be our y-intercept. What is it? Okay. Okay, y-intercept is where we start from. Okay, it's where we start from. The slope is the rate of change, and it's the change. We know that it's constant because it tells us that it's constant, so we know that it's a line, so we can assume that already. Okay, so I'm going to rewrite this over here. That's what, just write it as what we need to find. Oops. Okay. All right, M and B, those are the things. If in order to write the function, we're going to write it in this slope-intercept form. If we can find out what M and B is, then all we got to do is plug in the P, to write that out. So the rate of change, which is the difference in your total cost, which is your y values, synonymous to your y values, and the difference in your p values, which is your x values. Okay, so the change here for p is +3. Change here for t is going to be 720. Is that right? Plus 720. Okay. All right, so M is going to be 7.2 over 3. Okay? Which works out to be, if I look at this, 3 goes into 7 2 times. Okay? And there's 1 remainder. All right, so we have 1, 2, 3 goes into 12 4 times. So 2.4. Okay, now both of them, they're both going up, right? So that's going to be positive. All right, so if the change, which would mean that for each box the cost is $2.40. All right, for each box the cost is $2.40. Well, remember to find your y-intercept, or your starting point, you got to go to where x equals 0, all right? Or in this case, our x is not x, it's p. So we'll say p equals 0. Go to where p equals 0. Well, p is 1 right here, so I just skip back 1 time. Okay? I go backwards. Okay, so if I'm at 5 right here, and I go back 2.4, I'm going to say 5 minus 2.4, wouldn't that be 3.6? So 3.6. All right, would that make sense? All right, $3.60 if I add 2.4 each time, right? I'm going to get, if I add 2.4, I'm going to get 5. Now these, I'm not, going from 1 to 4, that's not the same gap, right? So yeah, I can't compare it to that because it's not the same gap. This is just 1. We found out what the rate of change is, and it's $2.4 per box, per 1 box, not per 3 boxes. All right, so my my y-intercept is going to be 3.6, $3.60. Okay, what is the function? It is t of p equals 2.4 p plus 3.6. Okay? All right. Here it is. It says slope. Do you know what slope is? That's what this is saying. Do you know what slope is? It says a line with a slope of 2 over 5. That means rise over run. Rise 2, run 5. 2 over 5 passes through point Q, and which 3 points of the following graph. So we're just going to create 3 points out of this. So we can start from here. We can start from Q, and we're going to say that m equals 2 over 5. 2 means rise. Rise 2, run 2, 3, 4, 5. Okay? I could also go back. I could go back 1, 2, 3, 4, 5, and down 2. Okay? And then on this one right here, I'm going to go up 2 and run 5 again, right? 1, oops. Okay, so this point Q right here, Q is at 5 comma 4. Okay, over 5, up 4, right? This point right here is at 10 comma 6, right? 10, 6. Okay, this point is 15 comma 8. All right, and this point right here is 0 comma 2. Okay, so we've defined other than the point Q, which is 5 comma 4. It says it passes through 3 other points. 0 comma 2. It's going to pass through 0 comma 2. It's going to pass through 10 comma 6. It's going to pass through 15 comma 8. The reason why I chose these is because these are whole numbers. It lines up right exactly on that. So if I were to draw a line on this one, right, it'd look like that. Right? Okay, down to the last one here. All right, it says Marissa is decorating 50 cupcakes for a school fundraiser. She starts at 11 in the morning, okay, first setting up her supplies and then starting to decorate. So it says, so her starting point is 11 o'clock, right? So at 11 o'clock, that would be the 0 hour, right? And so at 11:10, which is 10 minutes later from when she started, okay, she has 8 cupcakes decorated. At 11 or at 1:15 or 11, I think I messed up here. This should be a 1. Yeah, let me do that. Let me put that in as 11. At 11:15 a.m., because 1:15 is not a.m. In this case, it would not be. But at 11:15 a.m., so let's change that. Make sure you change that in your if you print it out, change that. So at 11:15 a.m., she has 14 cupcakes decorated. All right. So x equals minutes. Okay. And the y value is going to be cupcakes. All right. So if you kind of are looking at this, you notice they're 2 points. Okay. So 2 points at 10 minutes. Okay. Why is it 10 minutes? It's 10 minutes because Marissa started at 11. And at 11:10, there were 8 cupcakes. Okay? At 11:15, so 15 minutes after the starting point, there were 14 cupcakes. Okay? If she decorates cupcakes at a constant rate, at what time that afternoon will she finish decorating 50 cupcakes? Okay, so in this case, I would say the best way to do this is just to figure out you got to figure out your equation here, and then once you figure out your equation, then you can just go ahead and plug in 50 cupcakes. Okay, all right, so we have to figure out our rate of change, and our rate of change is change in y over change in x. So m is going to be plus 6 on this side right here and plus 5 on this side. Okay? Alright, so the rate of change is going to be 6 over 5. Okay? Alright, so if it's 6 over 5, right? If it's 6 over 5, alright, well, we're down here, and we can even write it, right up here. But if we go back to 5, we would go back 6 right here, right? And going back 6 would put us at 2. Okay? And then if we go back to 0, we go back to, if we take 6 away from 2, we're going to be at negative 4, right? Okay, so right here, when we look at this, we're going to say y equals 6 over 5 times x minus 4. Okay? Alright, so in this case right here, what we're going to be doing is we're going to be plugging in, so x equals 50. So we found the formula, and we're going to go ahead and plug that 50 in for x. Okay? So top and bottom, 5 goes into 50 10 times. So 60 minus, so 6 times 10 is 60. So 60 minus, so let's say 60 minus 4 equals 56, right? Okay, so 56 is what? 56 minutes. All right? So what does that mean? Well, at what time? So now we got it's not as easy as just saying 56 minutes. At what time did she finish decorating the 50 cupcakes? So at 56 minutes, she started at 11. So at 11:56 a.m. she finished decorating $50 cupcakes. Just abbreviate it, 50 cupcakes. Alright, guys, that's it. So like I said, rewind, go back if you need to, if you need to go over those things. It's all right there. There's 1 through 10. Complete this first. Go through it, complete it, and write it down. Make sure that you write it down, even if you just have to underline. If it's on a written piece of lined paper, just underline the things that I've underlined there. Write those things down, right? You're just going to write them down just like that. Make sure you label it. Here's number 10, here's number 9, you know. At the top, just remember, top right here is called Unit 1 Checkpoint 1 Review. You can put your name, date, and period at the top. Then just go through and understand those concepts. when you guys are writing out the graphs, okay, just draw a quick grid like that, right? You don't have to draw every single little, little square in there, but just draw an XY axis, and then just, label some points there. Try and spread them out evenly. Label some points just like that. Okay? That's it.